Welcome to the CSTRO. In this Python tutorial on SymPy package, we are going to solve a very basic and simple differential equation which is given by xn plus 1 equal to 5xn minus 1. So basically your differential equation is a discrete analog to your differential equation, and it contains a difference of your steps. So you have like xn plus 1, so n is your steps and you have xn. So the difference of these two steps comes as a sum value, so we have to solve it for the n, and then we can put n as any number and we can solve it. So let's do it. Okay, so for doing that, import some libraries. So import a library. So I will import SymPy. So from SymPy import a star. So this is basically your global importing. So it will like import everything from the SymPy. Now define symbols. Okay, so define symbols. So symbols we have n. Okay, so n equal to symbols. So you have your n, you can check it, n is a symbol. Okay, and now you can define function. Okay, function such that x. So x you can say here function and give as n. So give as x, right? So if you type here x, and if you give a argument, so this will take as a symbol. Okay, so this has got your xn, right? Now define the difference. Define the difference equation, the above equation. So we are going to put this equation as here. So you can put f as equation, right? And equation and give xn plus 1. So this goes here xn plus 1, right? Then give comma, right? So comma is 5xn. So 5 into 5 into xn and then minus 1. Okay, close it. So run it and run it if. So here you can see that you have defined your differential equation as a symbols. Okay, now we want to solve it. Okay, so solve it. So solve it. So for solving, type here solution, right? Solution equal to solve and see what it takes. So it will take your function and symbols. Okay, so give your function f, right? And you want to solve for your xn, right? Solve for xn. So now run it. Solution, what it returns. So here you can see this is your solution. Okay, right? Now you can solve it. So solve it for xn as an initial condition. Solve it for condition xn initially as 0. Okay, so xn 0 equal to 1. Okay, can give initial conditions, right? So for that, type here solution 1 equal to solve, right? Give function then x of n, right? And then you can give your initial condition x of n, x of 0 such that 1. Okay, now close it. Okay, then go to solution 1 and run it. So okay, so for that you need to go for your your R solve. Okay, so R solve. So here you can see that this is the solution for this condition. Okay, this. Okay, now you can put any n here and you get a general solution. Okay, so this way you can do it. So this is like without initial condition, right? And for the initial condition we have the solution. This way you can solve it. Okay, you can put to see what is happening. So this will change. Okay, you can put 6. This way you can change accordingly. With here solution gets changes. This is my solution, right? So this way you can solve it using SymPy.